Usually a dodge moves the player in a cardinal direction, but what if we rotated around the target instead? This tutorial shows you how to do just that without using rope motion animations, and we can set how far the dash will go around the target. Alright, so I just added a third-person character that we're going to be dodging around in a new map. So we can open up our third-person character, and we're going to set an event for us to trigger our dodge. I'm just going to get a keyboard event and bind it to left shift. Feel free to also just use the dash input that we made in the previous videos as well. And for a tutorial like this, being able to dash around a character, we want to get the information of the character that we're dashing around. I would recommend taking a look at my lock-on series if you want to use a soft lock or hard lock to be able to get that actor. You can also go through and make a line trace, or better yet, a capsule or sphere trace, but it's not going to be as accurate unless you have a strafing system set up. But for demonstration purposes, we're going to get actor of class. And promote the return value to a variable and name it target actor. And it is going to be a BP underscore third person character. You can also put this in the begin play if you'd like. It doesn't really matter where we place it. Because we're using a dash and dodge here, we want to make sure that we have a branch set up so then we can't spam the input. So we're going to promote the condition to a variable, and we're just going to call it dashing or dodging, whichever you would prefer. And compile it and make sure that it is not true by default. Then after we initiate this, we want to set our dodging to be true. Oh, and actually this needs to be on false. And then we check dodging to be true. And we're going to make two events. So for a custom event, rotate player. We're actually going to be setting the actor's location based on a rotate vector around axis function. So we can set our actor's location. And we'll split the invert. Essentially, we're going to be rotating either clockwise or counterclockwise around the z-axis, so we can enter 1 for z and leave x and y as 0. We need to have the angle of degrees, which we'll promote to a variable, and we'll rename it current rotation. And then we want the in x vector, which we'll promote to a variable, and we'll rename this radius, which is going to be how far away from the center point of this rotation that our character is going to stay at. And so that we have a anchor point for this, we're going to get our actor's location. Split the structured pin. And we need to just use the z value. So we can add and connect our return value for the rotate and connect that to our new location. And for this movement, since we're going to be moving around in a circle, we could be hitting objects. So we want to make sure that sweep is checked. Otherwise we could go through walls. Actually, we're going to disconnect this add, and then we'll split the pin, and then add z, because technically that will be different. And the next event we're going to make is going to be for our rotation. And this is going to be so then our actor can continuously face the target. So we'll just call it face target. And we'll set the actor rotation. And our rotation is going to be the look at rotation. So we can find look at rotation between where we are. So we can copy our get actor location, recombine the pins, say start, and then we'll get our target actor, duplicate our get actor location, and connect that as the target. And we do not want to have our dodge tilt upwards, downwards, left, or right, so we'll split the return value. Then we'll split the rotation, and we will just use our Z. So now we'll go back to our dodge input, and we are going to set a new timer. And off the event, we'll create a new custom event, and we'll call it move player. We'll set the time for 0.005 seconds looping, and promote the return value to a variable, and we'll call it movement timer. Then we want to call our rotate player event. And we want to change our rotation and update it. So we will drag in our current rotation. Then we will add. We'll just say 1 for now. Then we want to go back to our current rotation and set it. Then we will call our face target. Before our timer, we're going to set the radius. We're going to get a max float. And we can either use the distance between the player character and the target actor, or a minimum of 50. That way, if you have your player right up against the mesh, functionally it will work better to move the actor around its target. It doesn't push the character back too far such that it's jarring to the player. So get the actor location, duplicate it, we'll say our target actor, subtract, and then we'll get the vector length. And connect it to our max. Then we need some way to stop this. Since our current rotation, if we are going to the right, it'll be a positive number, and if it's going left, it'll be negative. We can't just check to see what rotation we have. Easier way to do this is to add a new float variable, and we'll call this desired rotation. Drag it in, we'll compile it and keep it at 0. And we could just add ++. Then at the end of this, take our desired rotation, check to see, we'll say over 90. So then this will go a quarter circle. Then when it does, we want to end this timer. So we'll get our movement timer, and then we will clear and invalidate timer. We'll reset the current rotation to 0, and then the desired rotation to 0 as well. And we'll leave this in its own event. And I'll call it end rotation. And then we also need to have our dodging set to false. So it's going to be a little wonky, but we'll test it out. Because our desired rotation starts at 0, essentially we're just going to be able to move a quarter circle just from behind the actor, no matter where we're at. In fact, if it tries to move us through, we might get caught on the actor, so we need to fix that. Right after we declare what our radius is, so we're going to set the current rotation. I'm going to duplicate the actor's location. We're going to take the player's actor, subtract its vector from the target actor, split the structured pin, then right-click and get a tan 2 in radians. Connect X to X and Y to Y. Then we need to multiply this by 180. Then finally, we divide by pi. So you just type in get EI. Connect it, and that is the current rotation. So that will, when we initiate it, get the current degrees of a circle that we are around our target actor. So now when we're standing in front, or from any angle, we'll just slide 90 degrees or up to our desired rotation smoothly. Next, to control the direction, we're going to go up to our IA move. And we'll promote the action value X to a new variable. We'll go down to our timer, where we have our control rotation. We'll select float. And A will be -1, B will be 1, and this will be dependent on whether or not our action value is greater than 0. So now if we're holding left, we dodge to the left, press right, we go to the right. So now we'll add in our animations, which we can call before we get to the timer. I just have the dodge left and dodge right montages from the previous video. So we'll just get a branch, check to see if our action value is greater than 0. If it is, we're going to the right, so we'll play the right dodge. Otherwise, we'll play the left. So we'll play montage. And you can do either the play montage or play and a montage. Dodge right, dodge left. Another step we can take is rotating the camera during the dodge. So we'll create a new custom event. We'll call it rotate camera. We want to get the player's controller and set control rotation. This is going to be called during our timer, so we're going to get rInterp to constant. We'll connect the return value to our control rotation. We'll get our follow camera and get its world rotation. And that is going to be our current. Our target will split. We'll get the find look at rotation. Split the return value. Our look at rotation will take the same information that we have here, our actor location and our target actor location. And we're going to connect the X and Z values. And we may want to move the camera up and down just for better control for the player. We'll take our world rotation for our follow camera and break the rotator, and we'll use its Y input. The delta time will be 1 second, interp speed 2 seconds. Then right after we have face target, we'll call rotate camera. So now when we dodge, we keep the camera attached to our focus. So as you can tell, depending on how far we are away from our actor, we'll still be able to move, and the distance traveled is greater depending on how far away we are. So what we might want to do, this is only going to be something that is unique to not having a lock-on system, or if we don't have a radius based on some sort of hit detection like a trace. We just want to check to see if the radius is within a bound, so then we aren't just able to dodge from an infinite distance. We'll use our radius and check to see if we are less than, say, 200 units. If we are, then we do that as normal, and then just copy our dodging, uncheck it, and set it as false, so then we can dodge again. And then you can adjust the distance as needed. Now, this is pretty much it, but I do want to go over one issue with this, just so then you are aware. If we try and dash up a ramp, it gets a little bit wonky. As you can see, we can go up ramps a bit slower, and then when we get to the point of getting to the top, we kind of teleport away. One way we can sort of circumvent that is off of our branch. The desired rotation is over 90, or we can get on movement mode change. If you want to have this dodge happen in the air, we can't just say, is the character falling? Because then we won't be able to initiate this. So we want to have it so then if our character is on the ground, but then it goes into the air, then we end the rotation. So get a branch. See if the previous mode was equal enum to walking. in the new movement mode, equal enum is falling. Then we end our rotation. So now we're not exactly teleporting. We just get to the end and then we fall off and it cancels the dash. If we wanted to do a little bit more hand smoothing, we take our action value X, and then we will get a select vector. We check to see if our action value X is greater than 0. Then we're going to use this to launch our character, either in the right vector or the negative right vector, depending on how we are moving when we end this rotation. So get actor right vector. Then we'll multiply. We'll convert the bottom to an integer and say 400. Then we'll duplicate the multiply and we'll say negative 400. Then launch character. And we can override the XY. So now our character is launched a little bit, so it's not immediately getting to the end and then falling down. You can increase the intensity if you'd like. And since there's a bit of snapping, another trick I like to do is just drag the camera boom to be a child of the mesh. And then we also want to add another pin to our end, and only do that if we are dodging. Otherwise, it's going to launch our character when we jump. There's also a bit of slowness when we get up to the ramp. So off of our rotate player, we can break the sweep hit results. This will work exactly like doing a trace. And if we are blocked by an object, we can either launch our character up a little bit, or we can add a movement input. Then we'll just get the actor's up vector. And we don't need the full scale value of 1, we could just get away with 0.5. There's a few tweaks you can try out, like setting the movement type to flying at the start and back to walking at the end, selecting different interp speeds if the radius is greater than a certain distance. Just try to experiment with it. I want to say thank you to all the pillars of the Patreon for their continued support: Winterberry Shark, Thatcher Moss, Francesco Poda, and K Panic. If you like these tutorials and want to help me out, you could check out the Patreon or become a member here on YouTube. Both give exclusive benefits and support this channel. Feel free to join the Discord for updates, to ask questions, and more mysterious future plans not yet revealed to the world. So with that, thank you all for watching, and I hope you've been inspired.